cooling and solidification. So we have already discussed the solidification of casting in the welding basics, and solidification is a process of transformation of a liquid to a solid. And in solidification, a solid phase is nucleated and grows with a crystalline structure. So if you remember that I told you that whenever the melting point or you can say the melting point of the molten metal is reduced to the freezing point, so at the freezing point the solidification does not start easily, so you have to reduce it somewhat below the freezing point, and that is called the undercooling. So when the undercooling is achieved, when the undercooling is achieved, some of the atoms are joined together and they become they acquire a shape of a nuclei, and then this nuclei must have a critical radius in order to stabilize and to initiate the solidification or the nucleation phenomena, nucleation stage. So after the pouring into the mold, the molten metal cools and solidifies. In casting process, you can perform the casting of pure metals and the casting of some alloys. However, the solidification of both the materials are different. A pure metal solidifies at a constant temperature equals to its freezing point, which is same as its melting point, and the process takes with time. So this is the cooling curve of a pure metal during the casting process, and you have plotted a curve, cooling curve between the temperature and the time. So here the pouring is performed, which is at this pouring temperature, and then you allow the molten metal to cool down. So here with the time, the liquid cooling takes place, and then the molten metal, or you can say the liquid metal achieves the freezing point. So here the freezing begins, and freezing is also commenced for some time period, and this is the end of the freezing. So this particular time period where the freezing begins and freezing completes, so this particular time period is called the local solidification time. However, from the time of pouring till the freezing is completed, this is the total solidification time. And here at the freezing is completed, and then you allow the metal to solidify into the mold cavity. So this is a particular cooling curve of a pure metal during the casting process. And during the solidification, so suppose this is a mold cavity, and then you pour your molten metal into this mold cavity, and I told you that the nucleation is performed in two manner. It can be performed, it can initiate in the form of a homogeneous nucleation, or it can also be performed or initiated in the form of a heterogeneous nucleation. And homogeneous nucleation is somewhat difficult in all the solidification of material, and heterogeneous nucleation, I told you that for heterogeneous nucleation you may require some pre-existing sites or some nucleating agents. So here in this case, the mold wall surface acts as a nucleating site, and here when you pour the liquid metal into this die cavity, the solidification starts, and here the heat transfer rate is very high, solidification rate is also very high. And if you remember our special curve of thermal gradient versus the solidification rate, so if you have high thermal gradient as well as high solidification rate, so you will have a fine microstructure microstructure formed inside the material. And due to that particular high temperature gradient and high solidification, high heat transfer, a thin skin of solidified metal is initially formed at the mold wall immediately after the pouring due to its chilling action. So here at the mold surface, these are relatively at very low temperature, and this causes this chilling action in the material, and the metal which forms the initial skin has been rapidly cooled by the extraction of heat through the mold wall. So at the mold wall there is a rapid extraction of heat, which results in the formation of this thin skin, and thin skin inside this thin skin the grains are formed by the heterogeneous nucleation, and these grains are very fine, and in a very narrow space, which is your skin, just like a skin, and here the grains are formed of very fine size. And you all know that as the cooling continues, again the grains, some of the grains present at this particular region, they will become, they try to grow, and they will get converted into needle shaped structure, followed by the dendritic shape. So this is the shape acquired by the grains which have grown, and they grow in a direction away from the heat transfer. So this is the actual, you can say, cross section of a solidified casting, and you can easily see that the grains which are just at the near the boundary of the mold wall, these are of fine shape and size, and however the grains emerging out from the grown grains, they are in the form of column, and it has acquired the dendritic structure. So the grain resulting from this dendritic grown growth on a prefied orientation, they tend to be coarse. So you can see the size of these grains as compared to the size of these grains, so they have become coarse, and they have columnar dendritic structure aligned towards the center of the casting. So the solidification commences from this side, and this side. So you will have this type of microstructure inside the solidified casting of a pure metal. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.